Everyone. Today we are going to solve LeetCode's 3532 path existence query in the graph. Today's LeetCode POTD. So question is like you are given an integer array n, represent the number of node in graph, label from 0 to n minus 1. You are also given an integer array nums n sorted in non-decreasing order and an array max difference. Okay. An undirected edge exists between node I and node j if absolute difference between nums of I and nums of j is at most max difference. That is absolute of max difference should be lesser than 0, then and only then there exists a path between I and j, right? So you are given also given in 2D integer array queries where query of I is equal to u of I and v of I. Determine whether their path exists between u of I and v of I. Okay, so this is the query array that we have to check whether there is a path between u of I and v of I. If there exists a path, return true in the boolean array, otherwise return false. So basically the question is like we are given the n nodes. There are some weights or some values given to the n nodes, a max difference integer number and a query array. Okay, so this nums is basically sorted in the non-decreasing order or basically in the increasing order, so its value always increases. Okay, so basically we will see this example. Okay, so now in this example we have four nodes. Okay, each node has this values and a max difference of and query of this. So basically what we have to do, we have to check whether for 0 to 1 node, for node 0 to node 1, there exists a path. And what is the condition for existing path? The max difference should be lesser than or equal to 0 or lesser than or equal to 2. Okay, so if we see 0 to 2, 0 to 5, their difference is 3. So there does not exist a path, so it is false. And same goes like for all of this. Okay, and if we see from 1 to 3, 1, 3, so 1 means 5 and 3 means 8. Okay, so if we see 5 and 3 difference is 5 and 8 difference is 3, but the answer is true. Why? Because we can go from 5 to 6. 5 to 6 means node 1 to node, okay, its difference is 1, so it is valid jump. And then node 2 to node 3 means its difference is 8, so its difference is 2, so we can also make that valid jump. So there exists a path between 1 to 3. So basically we have to find this whether there exists a path between the nodes or not. So this is basically a question of connected component. We have to find which component are connected and then according to that we can find it. Okay, so basically this is if we can see the nums is sorted, so we can use binary search, or we can basically simply use a disjoint set union. So if you have knowledge about disjoint set union, that's well and good. Otherwise, I will show you the implementation part, that how the disjoint set union works or how the disjoint set union looks like in CPP. And we will also solve it by another approach, which is binary search, or we can say pre-computation of nodes. Okay, so basically first we will start it by disjoint set union. So for uh, disjoint set union, we have to first define the DSU class. So class DSU, okay, this is the class. And firstly we will define the access specifiers, like which is the our private, and in private we will define the two integer array where we store the parent, and size we will do union by size. Okay, and then next access specifier is public. Okay, then we will define the constructor DSU. We will pass nodes to the constructor, and then just do parent dot resize and size dot resize. Okay, and assign the initial values to it. Okay, parent of I is equal to I, and size of I is equal to 1. Okay, this is the basic parameters. Okay, now we will try to do find parent. find parent of node u. In this joint set union class, we have two methods. First is find parent, and second is union by rank. Union by rank or union by size. So union by size is more intuitive. So if you doesn't have any idea about the disjoint set union, you can watch Striver's video. He explained it very much clearly that how the disjoint set union works. So yeah, we say union by size. So we have this two function. Now first, for union by rank as union by size, we have what we have to do. First, we have to find the parents of UNL. So find parent of U. So finding the parent of U, first we have to implement this class. So firstly, we have to write the base case. So base case goes like, if parent of U is equal to U, so we return U. Means, let's see, parent of I is equal to I, means if parent of 0 is equal to 0, then it is the upper parent. If parent of 3, then 3 goes to 2, 2 goes to 1, and 1's parent is 1, so that's why we will return 1 only. Okay, so it is the upper parent or ultimate parent. Okay, otherwise we will just do recursive calls. Parent of U is equal to find pair of parent of U. Okay, this is just path comprehension, not nothing much. The next we will find the parent of V. Okay, so now there is a case like if U, this is not U, this is U pair, U's parent and V's parent. So U pair is equal to V pair. So we will just return that we don't have to do anything. They are both in the same component. Otherwise, we will add them in the same components. So for like, if size of U pair is lesser than size of V pair, so what we will do? So if size of U component is greater than size of V component, so we will add U into V. So basically size of V pair, and how much size will V's parent increase? It's like U pair, and parent of U pair is equal to V pair. Okay. Otherwise, the opposite case, vice versa, V pair plus equal to V pair, not U pair, plus equal to size of V pair, parent of V pair is equal to U pair. Okay, so this is like the entire class. Now what we will do, we will try to make the components of the class. So for that, first we have to call the class function dsu pass the end nodes. Okay, the next okay, the nextly we what we have to do, we have to make the we will do uh, we will iterate on the nums array, and if nums of I minus nums of I minus 1 is lesser than equal to max difference, so bsu dot union by size, pass this u on it, pass this nums of I and nums of I minus 1. So what we have done here, if this condition is satisfying, this absolute value condition is satisfying, which is given here, so we will just do union by rank. And basically why we are just checking the adjacent, because if the condition breaks here, if 2 minus 5 is not lesser than 3, so if 2 minus 5 is greater than 2, means greater than max difference, so it is obvious that it is in the increasing order, so 2 minus 6 is also greater than 2 and 2 minus 8 is also greater than 2. So if we check the condition for adjacent only, and if it is failed in adjacent one, so it is not possible that it will further satisfy. So basically, if condition fail here, it will also fail here, here and here. So that's why we are just checking for the adjacent one. Okay. Now next is we will just make our boolean array and iterate on the queries. Okay. QVRIES. Okay. Now int not if we aside if dsu dot find pair of q of 0 is equal to dsu dot find of q of 1. If they are same, then answer dot pushback true. Answer dot pushback true. Oh, what the fuck? Okay. Answer dot pushback true. What is happening? Okay. Answer, otherwise, answer dot pushback false. Okay. So it is like this and return answer. Let's see, will this, okay, just wait a second. Okay, now we'll try to run it. Um, okay, it is giving heap overflow. What is the issue? For parent, when it is giving the heap overflow. Okay, this is the issue. I have passed the value. I have to pass the nodes I and I minus 1. Now will this, yeah, it is good. Now let's try to submit it. Yeah, we are able to pass all the test cases. Now let's see. I guess 4 alpha and this traversal and distributed time complexity. Let's see what it is saying. Genuine fine graph, not small value, different connected. No, consider you can optimize query to big of one pre-computing IDs instead of using upper pack and alpha and plus q. Okay. Now this is the first approach that we can use from the DSU. If you guys don't know about DSU, then we can simply use the pre-computation one. So I will explain you that approach also. So like I have said, if this two adjacent node doesn't satisfy the condition, the further will also not satisfy. So we will just set it. We will just store the pre-computed component inside this, and component of 0 is equal to 0. Okay, just iterate on the nums, and if nums of I minus nums of I minus n, it is lesser than equal to max difference. So component of I is equal to component of I minus 1. Otherwise, this doesn't exist, so we will just change the component and go to I plus I n plus 1. And okay, and now we will iterate on 2t varies. And if component of q of 0 is not equal to component of q of 1, then answer dot pushback false. Sorry, we'll just generalize the condition in this. Uh, True is answer dot pushback false. Okay. So this is how we can do it simply without using the DSU value. If you don't know about the DSU, okay. Yeah, this is also running fine. So this is how we will solve today's LeetCode POD 3532. This will basically you have to know about how the disjoint union work, or if you don't have idea about disjoint union, then you just have to notice this uh, fact that this array is sorted in the increasing order, so we can use the decomposition of arrays and try to find it. Okay, so this is how we can solve this today's question. So yeah, thank you for watching the video. Bye bye.